Hey, welcome back. This is another walkthrough video. Like the chi-square goodness of fit, I'm giving you a bonus video, just a walkthrough for the test of independence, how we're doing this in Excel. I will also repeat this with a second bonus video in R, just so you can get some more exposure to different data and processing through this before you get into the classroom and have to work on it yourself. So in this particular example here, we are using GSS data, General Social Survey data, and we are comparing to see if there are any relationship differences between men and women and their opinion on if somebody should be able to get an abortion for any reason. So abortion for any reason, that's just a yes, no. Men and women are male, female. That gives us a 2x2 table. So what we have up in the very top is an observed, where we see this 2x2 table. I have already added in data for the marginal rows and marginal columns as well. And what we're going to be doing is generating the expected values and then proceeding through the chi-square math process until we can determine if we are statistically significant or not. Before we start going through some of all of those, I'm going to jump down below to the helper cells to just see what it is we have going on. So the chi-squares, and in this case, the data points I'm referring to are in columns A through C, starting at row 31 and going through row 36. The chi-square on row 31 is for when we actually calculate the chi-square itself. DF refers to the degrees of freedom. So let's keep in mind that in the test for independence, the degrees of freedom are the number of rows minus 1 minus the number of columns minus 1. And we already said it's a 2x2 table. We could do the math that way. But let's say this was a larger table, and I want to go ahead and get some experience doing this computationally in Excel. So I'm going to hit equals up here, and I'm going to open a parenthesis, and I'm going to do count A, open another parenthesis, and I'll do the columns first. I'm going to highlight the categories for male. I'm going to close that. I'm going to minus 1, close my first parenthesis I originally opened up, multiply by, open another parenthesis, doing a second count A, open in a parenthesis, and now I'm going to select the yes and no. Remember, don't select the totals on these, just the actual categories. Close a parenthesis, minus 1, close a parenthesis, and it should give me 1. Number of rows minus 1 is 1, times the number of columns minus 1 is 1. 1 times 1 is 1. The Yates continuity correction. Do we need the Yates continuity correction? We only need that when we have degrees of freedom equal 1. So in this case, yes, we do. Chi-square critical value. This is the number we need to exceed to see if we are going to be statistically significant. And in this case, I'm going to go ahead and use an alpha of 0.05. So I'm going to look over at the degrees of freedom critical value table there for chi-square, and I'm going to go look up which particular critical value it is that we need. And I'm going to add in a couple lines here so it's nice and easy for you to see on your screens. So I'm going to look at the column that says 0.05 and adjust the color and lines here so it's nice and easy to see. And then let's also cross-reference this where we have 1 degree of freedom. And it looks like we have 1 degree of freedom when alpha is 0.05 at 3.841. 3.841 will be our critical value. So I'm just going to go ahead and type that over in cell B34. That is the number to beat. P-value, in order to get the p-value, we're going to need a chi-square value itself, and statistical significance, we need that as well. So let's go back up and start computing the chi-square. So up at the top now, I am in cells B7, starting there. We're going to look at the expected of men who said yes, you should be able to have an abortion for any reason. And in the test for independence, we compute our frequencies expected differently than in the goodness of fit. So in this case, we're going to go ahead and start with an equal sign, open a parenthesis. We're going to take either the row marginal or the column marginal first. It doesn't matter. They are reversible. Click on one of those and then multiply by the other one you did not click on. So in this case, I did column marginal of 804, multiply by row marginal of 837, close my parenthesis, divide it by the grand total, which is 1,810, and that tells me I should have an expected frequency of approximately 732. It has a decimal point, but I'm just rounding this for sake of conversation. That, and we are counting whole persons, but I'm not actually going to round this into a whole person here at the expected value, because as far as the math is concerned, it doesn't really think that we're working with whole numbers with people and things like this. So it's fine just to keep it as a decimal. When you are running this in R and the math's going on behind the scenes, it is also keeping it as a decimal as well. We'll just do our whole number rounding when we get to the very end, if we needed to think about these sorts of comparisons, whole individuals, things like that. So let's go ahead and keep moving. The expected value for women who said yes, equal sign, open a parenthesis, column marginal of 1006, multiply by row marginal 837, close the parenthesis, divide it by the grand total of 810, and I have an expected value of expected frequency of approximately 465. Let's go ahead and do the men who said no, equal sign, open parenthesis, column marginal of 804, row marginal of 937, close the parenthesis, divide it by grand total of 1,810, is an expected frequency of approximately 432. Equal sign for females who say no, open a parenthesis, column marginal of 1,006, multiply by row marginal of 937, close the parenthesis, divide it by the expected frequency of 1,810, says we have an expected frequency approximately of 541 rounded. Now that we have our observed and expecteds, we can go ahead and start computing the chi-square statistic itself. So I'm jumping down to cell B12, which is where we look at the O minus E for men who said yes. I start with an equal sign. I go up and click on the 382, male who said yes observed, minus the rounded 372, male who said yes expected, and it will give me a value there. I'm just going to go ahead and drag it down one and drag it right one. That's going to just copy the formulas down a row and then across a column. The cell references will move with it, so I don't have to retype all that out. And then because we needed the Yates continuity correction, we have to do a couple extra mathematical steps before we can get the chi-square statistic. The first one is we need the absolute value of the observed minus expecteds. And in order to do that in Excel, we need an absolute value function. So I'm going to start with an equal sign, and I'm going to type ABS. ABS is the formula for absolute value. So ABS, open a parenthesis. I'm going to go back up and click on the yes male value of 10.2 in the O minus E's. Close my parenthesis. And it tells me 10.2 with its additional decimals. Nothing changed as far as this because it was already positive. But when I drag it down one and I drag it right one, so it copies those over, all of those, any of them that were negative, will now be positive. And note, these all have the same value. That is not an accident here. 2x2 tables often have mirrored values symmetrically between the rows and the columns and whatnot, just because of those differences. Anytime you have two categories, whether it's in the row or the columns, you're typically going to see some symmetry. And when it's 2x2, it's often for both. All right, so the next step in the Yates continuity correction is we need to remove 0.5, subtract 0.5 from each of those cells. So I'm going to start with an equal sign, click up on the yes male of the last group we just calculated, the absolute values, and I'm going to take minus 0.5. That gives me a value of approximately 9.7. I'm going to drag it down one, and I'm going to drag it right one. It's going to copy all those values over. Now I'm done with the portions for the Yates continuity correction. I am back into the regular steps for the chi-square. So let's go ahead and do the squared part of it. Equal sign, clicking on the last reference we just did of that approximate 9.7. Shift 6 to get the up caret 2 because we're squaring. And that says the square of approximately 9.7 is about 94 and decimals. Copy down one, move it right one, and we have that all over there. Now, the last step before we do the summation, we are dividing by the frequencies expected. So everything we just did is in the numerator of our analysis. So I'm going to go ahead and click equal sign, click on that 94 and decimal points, click a division. I'm going to go back up to where I have the frequencies expected and click on my approximately 372 of the yes men. Click enter, and I have a value of about 0.25. I'm going to drag it down one, drag it right one, Now, where we had values that were all the same in the rows and the columns, these are now going to be different because we did have different frequencies up in our frequencies expected. So they should differ. That's perfectly normal. And now we begin to add up the chi-squares. So I am in B31 across from where it says chi-square equals, and I will click equal sign SUM, open a parenthesis, and I'm going to just click and drag around those 4 values in that little table up above, close my parenthesis, and add it down. I have a chi-square value of 0.847972. Now, just rounded, 0.85. Is 0.85 larger than 3.84? No, it is not. But if I'm having a lazy math day, I can make Excel tell me, equal sign, click on my chi-square value, greater than the critical value, enter, false, it is not. Let's go ahead and calculate the p-value that comes with this particular chi-square statistic. I'm going to do an equal sign, CHI. As I start to type it, I will get different chi-square type formulas that are popping up. I will choose the chi-sq.dist.rt, hit tab to auto enter it, or you can just keep typing. And then I will click on my chi-square value that I obtained, comma, my degrees of freedom, close my parenthesis, enter, and the p-value associated with this particular chi-square is 0.36 rounded. So this is far above our alpha value of 0.05, confirming the exact same thing we got with using the chi-square critical value, that we are not statistically significant. And if we are not statistically significant, we would fail to reject a null hypothesis that would say that there is no difference between men and women and their opinions if women should be able to get abortion for any reason. And so there is no association between them. They are independent of each other. And that will go ahead and conclude what we're working on here, and I'll see you guys in the second video for Excel.